Yes, good morning. Today we want to end our phase of specific capacity in physics. I told you earlier in the videos that it's going to be divided into three series. Number one, how to solve questions for capacity using a method of mixture. Number two, how to use the electrical method, and some supplementary problems. I've come to discover that apart from relating heat energy to electrical energy, there are some other forms of energy that you can relate heat energy to, like potential energy, all these potential energy basically. So I brought two questions that is not a mixture method of mixture, and it's not also electrical method. And the two questions are this. So I want to use it as an example. The major purpose of the video is to ensure that you know that it's not only electrical energy that you can relate heat energy to, but you can also relate it to other forms of energy, because based on the law of conservation of energy that says that energy can neither be created nor destroyed, but can be transformed from one form to another. So that's the reason why I brought up this new video, for you to know that you can also relate heat energy with other forms of energy. So let's keep watching. Let's see how we can solve these two questions. Now, a waterfall is 420 meters high. Calculate the difference in temperature of the water between the top and the bottom of the waterfall. Neglect its losses. So its capacity of water is 4,200, and gravity is 10 meters per second square. They've given us that. Now, in this question, if you look at it, they say that there is a waterfall. Water is falling from a height, and the energy that usually exists from a height is usually known as potential energy. Now, let's list out the parameters. That's the first thing we need to do. Now, height 420. Say that I should do for the difference in temperature. You don't know that. Because then C is 4,200 joule kilogram per kilogram Kelvin. G is 10 meters per second square. Now let's go for it. Now all we just need to do is that we say that potential energy is equal to heat energy based on the law of conservation of energy. So let's now check it out. Potential energy is usually mass times gravity times height, and that one is also mc delta theta. And that means they did not give us the mass, but it can cancel out. So the gravity is 10 times height, whereas the specific capacity is 4,200. And the height is 420. 10 times 420. Then the something is delta theta. So I can say that this is 4,200 equals to 4,200 delta theta, and that change in temperature will now be equals to what? 4,200 divided by 4,200. So the change in temperature is 1 Kelvin times 1 degree Celsius, depending on the temperature that they gave to us. Now let's see how we can solve the second question. It's also another question that we can solve. So the number two question, they say that a room with floor measurement 7 by times 10 meter, that's the area, contains an air of density of mass 250 kilogram at a temperature of 34 degrees Celsius. The air is cooled until the temperature falls to 24 degrees Celsius. Calculate the height of the room, the quantity of energy extracted to cool the room. Take all these parameters. So let's see how we can solve the second question. let's solve. Now let's list out our parameters. The area 7 times 10, so that's what 10 meters squared. And we all know that volume is area times height, so let's leave that one for each other. Then let's go for the mass is 350 kilogram. It's 250, sorry, 250 at the temperature of initial temperature theta 1. Theta 1 is 34 degrees Celsius, theta 2 is 24 degrees Celsius. So change the temperature. So delta theta will be equals to theta 2 minus theta 1, which is also 24 minus 34, and that's what minus 10 degrees Celsius. But we take it as 10 because we all know that there is a fall in temperature. We take it as 10 degrees Celsius. There is a fall in temperature. That's why it is giving us a minus. Now let's quickly solve for the first question. They say the height of the room. The height of the room. We all know, and they gave us some things like SHC of air. That one is 1010 joule per kilogram per Kelvin. And they also gave us density of air. Density of air. Density is 1.25 kilogram per meter cube. So let's see how we can solve this one now. We all know that density is equal to what? Equals to mass over volume. And if that is the case, then I can say that mass over volume, the density is 1.25 equals to the mass 250 over volume. I don't know the volume, but I can say that 250 divided by 1.25, and that will be what? 200 meter cube. So if I want to know the height, I said it earlier that volume is area times height. Volume is area times height. So you can say that 200 equals to the area, 70 meters square. 70 meters square times height. So height will now be 200 over 70. And that will be what? If I cancel this, I'm going to have 2.84 meters. So that's the value of the height. We are going to have 2.84 meters. Now, what other things do I need to get now? What I need to get is the quantity of energy extracted. The quantity of energy is the heat energy there, and that's what MC delta theta. So we have the mass 250, the specific capacity 1010, and we also have the change in temperature as 10. So what are we going to have there? We are going to have don't have a calculator here. 250 times 101. So let me have 0, 0, 0, 5 times 101. So this one will be 25 times 101. That's a 2525. So 2525. So it's going to be 2525 joules. So this is the amount of heat energy that is to be in the room, because you have to multiply this by this by this. So that's and I can say it is a 2.525 megajoules. I hope you find the video so helpful. If there is any complaint, you can comment, and if you like the video, please click the like and also subscribe to our channel if you are just new to the channel. Thank you so much, and God bless you.